now because it's all really exciting. And while you do that, I'll admit more people and I will also drop the link to the paper in case people haven't read it. Please do. It's really excellent. And before I actually hand it over, I want to say thank you to Mozilla AI. We've partnered with the researcher affiliated with Mozilla AI to produce this edition of the Paper Club, which is focused on agents. And that is one of the papers that right away we knew was special. So over to you. Thank you for joining.
Thank you so much, Elena. And yeah, good morning from San Francisco to all of you. Super excited to be here. And sorry for all of the ones who kind of joined last week. I think we had some miscommunication between Elena and me on terms of the scheduling. But now we're here and excited to talk about AI agent evaluations and my research. I'm kind of personally was a PhD student in Princeton computer science. And for the last 2 years and now kind of since a couple of weeks moved to San Francisco to start a company with 2 co-founders called Ludus Labs. And yeah, I'm going to talk about both my research and the company a little bit, mostly, of course, about the paper. So maybe let's jump right in and I'm going to share my screen. I'm going to talk for around like half hour max and kind of go through the paper and also some adjacent research. And then I'm super excited for like the Q&A in the second half of today's paper club. Yeah, so the remarks I want to give kind of are titled Building and Evaluating AI Agents That Matter. The title of the paper is AI Agents That Matter. And most of the work, especially this paper, of course, is together with Sayesh Kapoor and Arvind Narayanan, my advisor at Princeton. So just to flag that up front here. And kind of when we talk about AI agents, of course, like many of you work on agents, but like we usually talk about a system that has somewhat of these components, right? Interacts like with tools, has memory, does some planning when making decisions, and interacts with, generally speaking, some sort of environment in order to solve more complex tasks that like a language model alone cannot solve. This can mean like software engineering or completing tasks on the web, but also just means like, you know, a regular chatbot that I guess most of us use every day, like Claude these days, are also agents of some sort, like maybe the simplest kind of agent, because they can execute code in some sandbox, now do web search, etc. Then, of course, Operator is like a great example for like a web agent that I just mentioned. Deep Research, you know, uses the web and browses the web to come up with like lengthy research reports about a given prompt. And then, of course, like we can also think agents a little bit further with like this example from the movie industry, or also some products kind of that I think we can think of as agents that like didn't turn out so well, like the Humane Pin, etc. So kind of today's, I thought like a couple takeaways that I want to structure my remarks in the beginning. Are first, evaluating agents is hard, and I'm going to give some examples why it is so hard, which then motivated also sort of like our paper, AI Agents That Matter, which kind of discovered many of these pitfalls with current AI agent evaluations and like pointed to concrete solutions of how we can overcome them. And then kind of given that the paper is, I think now almost a year or like old in terms of like when it was first published, I also want to give some like thoughts on like what's next for Agent Evals and talk about the company, Ludus Labs, that I'm co-founding. So first, like why are Agent Evals so hard? I think I want to kind of motivate that with an example. One of the most prominent sort of like tasks for agents these days, but also products, and that is like Swebench, which is like an excellent benchmark from colleagues at Princeton, that kind of tasks agents to solve GitHub issues and resolve them. And like one thing that is so remarkable about Swebench is that, well, first of all, it was a very early agent benchmarks, but also kind of how consequential it has been for the community outside of research in terms of like financing decisions made by venture capital funds, for example. And like one example is this startup Cosign that you know, last year in August broke the state of the art on Swebench. Back then it was like 30%, and then like just weeks after kind of raised like a pretty big funding round, just basically given that they kind of cracked the state of the art on the benchmark. The other example, a more prominent one, I guess, is Cognition, that like increased their valuation of their company just weeks after they raised the previous round dramatically, and kind of raised at a crazy valuation, like $2 billion or something. Mainly also just because they kind of, you know, broke the state of the art much earlier in the year last year on yeah, on three bench, as you see, like with close to 14%, much lower than what we see now with like closer to 70 or even 80%. And the problem is though that like, with a result like Bench, although it's like a great benchmark and has seen like many iterations with like, annotating tasks, verifying that they're indeed solvable, etc. It's truly a really good benchmark. There's still problems with that of like how informative it is of the actual like sort of like agent quality or agent capability in practice when actually used sort of like by users. And like a great case study that I would really recommend is like Thoughts on a Month with Devin by the Fox over at Answer.ai. And like what they did is kind of they used Devin in like and the first sort of big version of Devin that was released in their workflows, and then kind of they describe in the report of like how they used it, and like they really thought that like, hey, we're gonna pick like 20 tasks that we have to do like recurrently and that are kind of very common in our workflows, and they kind of found and described that only 3 of them they would really classify as successes, where Devin sort of like help them in like in their work or was able to complete them successfully. And for like many of the other tasks, the problem was usually that it's like that Devin produced unpredictable failures. Sometimes took like much longer for something that they thought is like an easy task, like days to solve something. Like they describe here, would spend days on something that is like they would consider a simple task or produce like impossible solutions rather than recognizing that there was a blocker, and with that kind of basically ending up in this infinite loop. And like this is not to blame like a company or a benchmark or whatever. This is just to say kind of that even though we have like incredible high accuracy numbers on benchmarks, if they're actually employed in downstream, if agents are actually used and deployed in practice, there's still many issues that we just don't capture with these sort of static benchmark tasks. So agent evals are hard. Another example is like from AI for Science, right? Like where they claim out of the lab in Japan, so Canada, the I was they released a paper again last year about like basically that they have achieved an AI scientist, so like an AI agent that can kind of give them a prompt, run experiments, write the code for them, to plot the results, understand the results, and then kind of produce an entire paper, which motivated one of our like papers out of the group in Princeton, led by Zach Siegel, called Core Bench, where we kind of wanted to check this claim of like how possible like autonomous AI scientists sort of are. And we picked an easier task that is part of the ladder of like science, which is like reproducing existing papers, like AI reproducibility in that sense. And what we did in that benchmark and what the task is still is like that we have a task like reproduce sort of these and these results out of a paper, and we also provide the agent with the full code base and the data necessary for doing that. Then the agent tries to go off and solve that with access to like a Python interpret, like a command line tool, first a full sort of like coding environment, and then like produce an agent report, which is like, for example, give an accuracy number that like that from an experiment that was part of the task. And yeah, the benchmark consists of like close to 90 papers from like many different disciplines: computer science, medical science, social science, and has like 3 sort of like different difficulty levels for each of the papers, with an easy task, a medium task, and a hard task. And we have papers from like experiments that are implemented in Python and R, so like have 2 different languages. And what we find kind of counter a little bit to the claim that from the Sakana paper is that actually like even for this much simpler task of reproducing existing code and running experiments, that the best performing agent with back at that time when we ran the experiments for the papers, Cloud 3.5, was not even able to like achieve to reproduce more than 40% of the papers in our benchmark. So kind of we found that it's not really like accurate in the sense that of like what kind of current capabilities for AI agents are, despite being a much simpler task. And the reason for that is kind of as prominently discussed in many blog posts and on Twitter, is like that the task kind of that was used to evaluate the AI scientists was actually much simpler, where basically they used like 4 existing code bases as templates, and the tasks that were part of the benchmarks for like creating these papers were basically just like tiny little like tweaks of these code bases and experiments. And then like the agent was indeed able to make sort of like these tweaks and then like write up like, of course, like a lengthy report, and like voila, like this is the paper. And that worked pretty well, but it's of course nowhere close to sort of the real task of the scientist, etc. There was also some follow-up study with like something related to like an AI agent kind of optimizing CUDA kernels, which also kind of where the agent mainly was going off on a second look, basically tweaking the reward function that they use for evaluating and benchmarking how fast the optimized CUDA kernels really are. And not so much kind of what they thought first, that like they're actually like the agent's actually able to kind of develop better kernels. So like what I'm saying here is like, again, not to blame any lab or any company, but like this is really hard, and like making claims that are reliable is like has proven to be very hard and like mislead people in the past. So kind of with that, the motivation, AI agents that matter, kind of how do we get from there to like something that like is more reliable for something that is as complex and dynamic and often operates sort of in open-end environments like AI agents. And in the paper, sort of we kind of have these couple different findings of like what an AI agent evaluation and benchmark kind of should look like. And the first one is kind of that for agent evaluations, we really need to move away from like one-dimensional sort of like leaderboards towards something that is a more holistic understanding, like a multi-dimensional evals. And the reason for that is kind of that one-dimensional agent leaderboards are misleading, and that is because that maximizing accuracy can lead to unbounded cost. And that is like maybe on first sight sort of a little unintuitive, but basically the reason for that is that by that an agent usually, like, of course, does not just consist of like a single language model call, right, but like can sometimes have hundreds of thousands or even hundreds of thousands like language model calls in the backend. And with that, it kind of what this can lead to is something that like a state-of-the-art agent on some leaderboard might just be a function of like how many times of the language model was called, or like one step further, how much money was spent to actually solve the task, and with that, of course, how much compute was spent. And this kind of trend is something that has been like recorded in like many different sort of like papers. I think the earliest one that I know of is like AlphaCode, like a coding benchmark, a paper out of DeepMind, where they showed that kind of by just resampling from a language model on a given like coding task, we can actually achieve like a log linear increase in accuracy just by basically resampling. And this trend holds for like many orders of magnitude. And we can go from something like 0% on like one zero shot accuracy, like with one model call, to something that is like closer to 30%. If you have like or even above 30%, if you create a model like a million times. The same holds for like a math tasks in the middle. Snell et al. In 2024 showed that this holds, and then like the large language model monkeys paper out of Stanford kind of showed this again on like tasks like SweBench and like multiple other coding tasks. So, but if that is true, kind of what can we even like use leaderboards like that, which is like which was the leaderboard when we started writing the paper on the human eval coding benchmarks, that kind of only report accuracy, passive one accuracy, but nothing else. Like this question of like that a leaderboard should answer, I think like what is the best agent on human eval is something that, given what we've just discussed, is like really hard to answer. So we thought like, okay, what kind of first of all, what metrics and what sort of visualizations should we look into for answering that question successfully? And then we actually set out in the paper to do that for the human eval benchmark. And the first question we answered with something that is like a very sort of like a popular concept, of course, Pareto frontier. So we kind of look at two different metrics, the accuracy on the y-axis, and then the cost, the dollar cost spent on solving the benchmark on the x-axis. And that allows us to kind of see, how much money basically is necessary in order to achieve a certain accuracy in the benchmark, and with that make decisions on like or inferences on like what is the best sort of agent given the cost accuracy trade-off. And so for the paper, kind of quick, like what we did is like actually we reproduced the top three sort of like open agents at the time, which were related to first of all like the reflection agent, LDB, and LATS. And what these three basically do is like that, given that each human eval task provides a couple unit tests that kind of give a signal of correctness. The first agent kind of reflects on what might have gone wrong in case a solution doesn't pass all of the unit tests, and then like tries again. The LDB agent, D stands for debugging, kind of tries to debug the existing solution before submitting it again and running it again on the unit tests. And then the LATS agent does tree search, kind of to find to explore like multiple different solutions in order to like find a passing one to the unit tests. So we validated cost in addition to accuracy, as we've just discussed. And then also we kind of added some like simple baseline agents in order to kind of have like a stronger baseline of actually seeing like how much these like more complex approaches add in terms of accuracy and at what cost on the human eval benchmark. And what we did there is that we kind of first we had a retrial agent that just like kind of naively retries. We had a warming agent that across retrials kind of increases the temperature of the underlying language model sampling. And the third one was something that we call an escalate agent that kind of after a given candidate solution failed the unit test, fell back to like a more powerful model, but also more costly model to come up with a hopefully passing solution on tasks that require indeed a stronger model. And yeah, the three key results kind of is first this new form of like visualizing agent evaluation results with our kind of Pareto frontier here on the left. Then the sort of like the main takeaway is that first of all, our simple baselines with the warming agent here on the left and also the retrial agent indeed like outperform the state-of-the-art agent at the time, which is the LDB agent. But and I say outperform because they get the same accuracy, but at a much lower cost, like twice as cheap basically as LDB. The second is the drastic differences in cost that we see here across these like agents on the leaderboard, LDB, reflection, and here towards the very right on the LADS, the tree search agent. And kind of I want to point here to the fact that we kind of truncated the x-axis. So like we really see here that like the LADS agent is like more than 20 times more expensive than LDB, and even achieves like a lower accuracy for all of this compute spend and token spend kind of during the tree search. And then lastly, given that our baselines perform so well, it is kind of unclear what the sources of the performance gains here are, like what actually like makes an agent better, and like how kind of useful are these sort of like system two like thinking approaches that they used at the time, with like prompting a model explicitly to reflect on its outputs, etc. Great. And then kind of in order to see all of that, the Pareto curves are necessary, and in overall kind of cost-controlled evaluations are necessary for agent evals. And that is like one of the sort of the key takeaways of our paper that we wanted to like make in the work. The second one is that given that we now motivated and saw like how looking at cost in addition to accuracy can be useful in like gaining insights that are relevant to like downstream deployment decisions, is also that we kind of then open up this new design space almost for agent developers of not only thinking about like optimizing your agent scaffold and kind of the choices for backend models, etc., for accuracy, but like for accuracy and cost jointly, which is of course something that by now like many people think about in when they kind of make deployment decisions for agents. But at the time, and I think it's still underexplored of like the possibilities that are there. And like when we say like jointly optimize accuracy and cost, like some quick things that you can think about is like using shorter system prompts for the agent, like refining few short examples, for example, that are used in the agent scaffold, like that have the same sort of value, but like just use up less tokens. We can do model routing, like picking cheaper models for like simpler subtasks that the agent needs to solve, and like maybe more capable and more expensive models for harder tasks, prompt caching, etc., etc. And in the paper, kind of we gave a very simple and rudimentary, let's say, example of like how this could look like, building on the DSPy framework that comes out of Stanford and is developed by Omer Kassab et al. That kind of really sort of like abstracts sort of like the primitives of like coding with language models, and with that also kind of building out agents, and comes with a whole set of like optimizers of like optimizing the different prompts that are used along like a language model pipeline or along kind of an agent scaffold in like in a principled way. And we kind of built one of these optimizers ourselves, adapted a little bit to also kind of not only optimize for accuracy but cost. There's more details in the paper of how we did that, but it's really like very simple. And what we found is that like on the hotpot QA, like question answering benchmark, which is one that we picked because DSPy really uses it as an example also of like where the framework shines. We find that by using our custom optimizer that considers cost, we can cut costs almost by half and at like basically no cost of accuracy. So we achieve the same accuracy at half the cost just by jointly optimizing those two. And we have a bunch of baselines that kind of show that this is like robust to like instructing the agent to like follow a given output format that is desired, etc. So this really motivates, I think, like exploring this design space more of like how can we think about more advanced techniques to do joint optimization of cost and accuracy. And there's a bunch of cool work that came out since then, but like I think it's still underexplored. And then the last one is like that motivated our some of you might have heard of it, our like efforts in like the holistic agent leaderboard is that really like working on this paper showed us this like crazy lack of standardization and reproducibility for many of these agent findings. So like with standardization, I mean like in reproducibility, I'm getting into the details, is that like different evaluation results reported on the same benchmark were indeed like run on like different test sets, different sort of with different scoring harnesses, etc. And are in that sense like not really comparable, and also some reproducibility issues. And like the first thing I want to get into here is like that in order to standardize agent evals, we need to understand that there is like a difference between agent and model evaluations, and that sometimes like not appreciating this difference has already led to like misleading claims in the past. And one I think cool example is like from is this plot that was released with the Mixtral releases back in the days where they on the x-axis plot cost and performance on the y-axis, like we just did with the pre-different here. But what they use here as cost is basically the active parameter count that is used at a given inference forward pass. And that shows kind of that here Mixtral is like has the same cost in terms of active parameters than the Llama 213B at the time, but achieves a much better accuracy. And this is of course like super useful when we compare models. But now if you kind of use these models actually as a backend model for an agent, for example, and look at and you looked at the API cost back in the days, then we found that like like using the mixture model is actually almost twice as expensive per million tokens than Llama 2. And of course, according to this graph, kind of they cost the same. So like if you look at agents, we need to consider API or like dollar cost. If you compare models, like proxies for cost, such as active parameter count, are indeed useful. Then kind of from the paper, just gonna go quickly through here is like this lack of reproducibility and lack of strong baselines that I just described. So like again, these agents that I mentioned, LATS and LDB and these papers, we found that kind of, and this is like unfortunately very common in like many papers, is that like reporting these results, some kind of by repurposing model benchmarks for agent work. Sometimes there is this like weird effect of like where model benchmarks are not really amendable to AI agents, such as for human eval, for example, 3 tasks in the test set were lacking the unit tests that these agents require in order to kind of iterate on a solution. And then like what one paper did, for example, is they kind of came up with their own unit tests, and others just removed these 3 problems altogether, which of course like leads to the fact that these results kind of were reported on different subsets of the benchmark, which kind of makes it hard to like really compare the results, especially if there's only 164 tasks. Then other benchmarks, if like other papers, when we reproduced their results, we actually found that like the baselines were pretty weak, and we recorded like much higher results if you rerun their code, for example, for LDB. And also for one other paper, we found like a little bug in their scoring code, which kind of made some of their results, which changed some of their results from the paper. And this, of course, like mistakes happen in science. It is again not to like blame any authors or like any specific sort of paper, but it's really like it shows the motivation for standardizing evaluations and having them sort of run by like a third-party platform to kind of overcome some of these issues. And then lastly, like a kind of problem with current agent benchmarks is that like that we also came up saw in the paper is that half of them, and we looked at over 30, don't even come with a test set. And of course, like this is very understandable given the effort and resources that have to flow into building a good agent benchmark. But from like traditional machine learning practices, like releasing a benchmark with only a train set that, for example, or like a public test set that people use to train on, is of course a practice that was very established, and suddenly for agent benchmarks, we're not really like, unfortunately, doing that anymore. And like many agent benchmarks come without test sets, which then leads over time, of course, to like people optimizing their agent for the full benchmark, and with that like contaminate the results almost, which is like another problem that we kind of motivated one of the big sections in our paper, where we kind of gave a principled way of thinking about how to build appropriate test sets for a given agent benchmark, and how this is like connected to the task and the intention of the benchmark creator, of like what kind of task the benchmark should actually measure. Yeah, and I mentioned kind of that like all of these issues with standardization, reproducibility motivate sort of like a third-party platform for evaluating and standardizing these results. And this is something that we have also already seen from like the language model community, right? Like where many similar issues actually were happening. And the prominent examples here are the Helm out of Stanford, the OpenLM leaderboard from Hugging Face, and like our effort in Princeton that we're doing is like similar, but for agents, which is called the holistic agent leaderboard. And at the holistic agent leaderboard, like kind of we want to be like the one-stop shop for agent evaluations, and like solve many of these issues that are just discussed, and standardize and like make agent evals like cost aware by default. We already support like more than 100 agents that we have listed in our leaderboards for like close to 15 benchmarks, and many more are going to be added in the next couple of weeks. We have This is like a subset of the benchmark that we currently support from various domains, right? Like that's where we call it the holistic agent leaderboard. So we have coding benchmarks, we have AI for science benchmarks, we have web agent benchmark, safety, cybersecurity, etc. To really kind of give a domain where you're interested in like looking into what is the state of the art of agents, have like a sort of a holistic overview of performance and capabilities. Great. I'm gonna, this is kind of, some of the results that we show for any given benchmark on the leaderboard. But I'm gonna, skip over those a little bit in the interest of time. And I'll get to the last part of what I wanted to talk about today, which is kind of what's next for agent evals, right? The Agents That Matter papers have said like close to a year old. I'm super happy that like, many work that came out since then adopted some of the suggestions that we make in the paper, such as cost-controlled evaluations, and like using standardized sort of like harnesses to run evals and report stronger baselines, etc. So kind of what's next for evals, agent evals, is kind of, first of all, this difference between capability versus reliability. So capability is something that is captured like, by accuracy, what an agent could do maybe if like a benchmark is perfectly capturing sort of like it's perfectly construct valid and like measures what an agent is capable of doing right now. And with reliability, we mean like what an agent could do consistently, so across reruns, and like fully predictable in terms of like when an agent is also making errors, or like abstaining from answering a question because the uncertainty is too high, etc. This is all kind of playing into the reliability part. And I think like current evals focus mostly on capability and not at all about on reliability. But like given that, but reliability is kind of what is the current bottleneck for agent adoption. I think that is fair to say for many sort of application scenarios, because if you have a technology that is like has 5 nines of reliability, like like that we achieved over decades for airplanes, for example, or nuclear power plants, then we can actually adopt the technology because we know its limits and we know where it works really well. And we have to achieve the same for AI agents in order to like make them really useful as like a technology that we can adopt and roll out as autonomous sort of agents for many use cases. And the problem there is like, how do we actually capture these sort of two notions? And of course, capability is pass at k, right? Like, so 1 out of like k attempts is indeed correct, and the agent is in theory capable of answering a certain task or like resolving a certain task successfully. And reliability is something that can be captured, for example, by this pass to the power k metric, which means that like each of the k attempts that the agent did was indeed successful. So the agent is very consistent, very reliable, and usually doesn't make a mistake given a task. And like when we compare these two metrics, as has been done for like one super prominent agent benchmark called TauBench, then we actually see that like current agents, due to the stochastic nature of the language models, of course, have like a very sort of steep path to the power k curve, where like if you consider like 8 trials, for example, or like maybe closer to 16 for a given agent, then like the accuracy drops from like 60% to something closer to 20. So like the agent is indeed like not very reliable. And like optimizing that and like making this curve like much flatter is something that I think is like super interesting research direction, but also something that like evals should capture better and like by default report these sort of two metrics. Yeah, verifiers are one way, of course, of like doing that, right? Like just catching basically wrong attempts by the agent and then just asking it to retry. I wrote a paper about like the imperfections of like verifiers and like the dynamics that are introduced. If the verifier indeed sometimes causes false positives, so like accept a solution that isn't correct, and like what that does with the inference scaling curves. That are banded down. I'm kind of pointing to the paper here, the limits of LLM resampling with imperfect verifiers for people that are more interested in that. I'm going to skip over it here. The second quick thing I wanted to mention is dynamic evals. So we talked about sort of the promise of like and kind of huge impact that static benchmarks such as Sweetbench and others have. But I truly think that like the future direction for like agent evals should be dynamic, given the dynamic nature of many of these tasks that we want to use agents for. And one such thing is, of course, like human in the loop. We use agents together with humans usually, so we should also evaluate them together with humans. And one cool paper here that makes a suggestion of how this could look like is who validates the validators that kind of have this loop, the eval gen pipeline, where the human evaluator kind of iteratively refines the criteria. Now, a new paper in terms of for the cybersecurity domain called Dynamic Risk Assessments for Offensive Cybersecurity Agents. We make some suggestions of like why it's so important to look at dynamic evals for the cybersecurity domain. And then like a new paper here that I really liked called Video Game Bench, and a new benchmarks model in kind of video games, which of course are also like highly dynamic and like not really a static task that you can overfit on. And then lastly, just like 2-3 minutes about like our sort of like company and the new direction that I'm personally super excited about is like moving from the language domain into embodied AI and embodied agents, which I think is going to be the next big thing. The company is called Ludus Labs, and I've my two co-founders, Gianluca and Benya. And yeah, what are we doing? So we're doing basically focusing on physically embodied AI. So like one kind of core premise that we have is that physical embodied AI is improving indeed. Like there's a bunch of cool work happening in terms of drone racing, where sort of continuous control policies beat the state of the art. Drone pilots, the world champion, achieve world champion level performance. Table tennis is largely solved by these agents. They can do really cool tasks in other sports such as basketball and like super complex tasks in also like home appliances such as laundry folding, etc. So like this is really happening, and like we're gonna have more and more immersive sort of like physical agents in like many domains of our lives. And one of that is of course like the era of robotics that is coming that I just mentioned. Like there's hundreds of companies that are building autonomous robots right now, including humanoids, and kind of what we don't really know is like how good they really are. For example, there's only like Unity sells humanoid robots already, but like many other companies don't really, and there's no such thing as like a standardized leaderboard that we have for like language models where we can judge like how good each of these companies indeed are. So like one idea is like to create sort of like the Hugging Face for physically simulated evaluations, and like that is truly missing, which is something we're excited about. And also, and that is kind of the new thing here, is that with physical and embodied AI, suddenly things become visual, right? Like so, and also entertaining. So we think that like by creating these evaluations, there for the first time will not be only the means to some end, but an end to themselves. And like there's of course some examples from science fiction, like with Real Steel, there's like robots running marathons. We had like robot boxing tournaments a couple days ago, and like all of those like were like literally like watched by lots of people around the world, and but can also serve as like a dynamic way of evaluating embodied AI and robots. And we think that kind of these two things, like the entering the era of robotics and entering the era of AI as entertainment, is something that we can kind of merge together, and with that kind of create sort of like AI sports, that and sports in the meaning of entertainment, but also sports in the meaning of like for the developers, sort of like building better systems, and with that kind of create this dual promise of thinking of AI sports as a scientific mass collaborations with having static dynamic environments for benchmarking agents, but also kind of hosting tournaments that are watched by people, where we can get young people excited about physical AI to watch that and produce sort of the next generation of like AI developers, and kind of create this flywheel between the two. There's some really cool examples that I'm not going to dive into here of like agents playing basketball in a physically realistic simulation, or table tennis, or like discovering the Fosbury flop and high jump in simulation. Yeah, but that's it, I think, for my remarks. Sorry, I went a little bit over time, and thank you so much.
Amazing. Thank you for the wonderful presentation. Lots you packed in a small amount of time. So we'll jump into questions, and I will jump into the chat. But while I'm looking and unmuting the right people, Joe, welcome. And do you want to say a few words? Or
Sorry, I
maybe,
was late.
yeah.
Thank you for joining us. This is an awesome and amazing topic. So thanks everyone.
All right. So I am unmuting Tillman so you can ask your question directly.
Hello, yeah. My question is, since you're moving from LLM agents to embodied agents, is there anything from the AI agents that matter paper that you think any aspects that have parallels in embodied agents, or that the robotics people can learn from this LLM agents discussion?
Cool. Yeah, no, great question. I think there are indeed some parallels. For example, the one is like looking at cost controlled evals, right? Like for AI sports and sort of the tournaments and competition we're gonna host, one big question is how do you make things fair to some extent? Like if you benchmark sort of like algorithmic advancements in like training better, AI basketball agents, like better like continuous control policies, then one thing we need to take care of is the model size, for example. If we have like a larger model, then of course you can like train a more sort of complex policy. But we want to control for that, and with that sort of like have different weight classes for each sport, and like weight classes literally in the sense of like how many parameters there are, in order to have sort of like cost controlled evaluations. And cost meaning here, of course, like more a raw form of compute cost, and not so much the dollar cost that we consider for the language agent evaluations.
And Jonathan, you can go next.
Hey, thank you for the presentation. Quick question. You mentioned very briefly who validates the validators. Can you expand on that a little bit on how you might think that will occur?
That's a really good question in terms of human in the loop in this whole process and where that even lands.
Yeah. Yeah, so this is a paper by Freya Shankar out of Berkeley. Kind of point to that paper also, of course, but like basically what their EvalGen pipeline describes is that that as kind of the target of like many of you might be familiar with Goodhart's law, but as sort of the target of an evaluation becomes sort of the outcome, as the metric becomes an outcome, it kind of loses a little bit of its value. And oftentimes, and the second thing is like oftentimes when evaluators sort of design a benchmark or want to judge like how good an AI agent is for their specific deployment scenario in some like industry context, let's say, it's kind of hard to really like come up with a metric that tracks performance accurately and like covers all of, let's say, the edge cases where the agent might fail, right, and like correctly sort of penalizes them. So the idea is like to kind of have this human in the loop pipeline where you look at the traces that an agent produces and solving a small development set of the task, and then kind of refine the metrics through that to kind of iteratively get to something that is like much more reliable. But yeah, the details that I kind of have to point to the paper. This was just really an example from like for dynamic evals and human in the loop evals that I liked.
Great. I'm asking Igor to go next.
Hi, everyone. Thank you so much for a wonderful presentation. My question is it possible to extend your framework to add security to cost and efficiency? I think that would be amazing evaluation for the real world business implementation of the agents?
You mean in the context of cybersecurity?
Correct.
Yeah. So kind of for cybersecurity, the reason why we wrote this paper, why dynamic evals here are necessary, and like is two things, that the cybersecurity domain is actually very particular, and that is mainly, first of all, we usually like have a pretty strong verifier available in the domain. Like you kind of think about like you want to decrypt, some message, and then suddenly sort of the message makes sense, right? You can read it, let's say, in natural language. Then the adversary indeed knows that they achieved the task. Or you want to do some, attack a web server and bring it down. And of course, like the verifier here is like if indeed the kind of the website is not longer reachable. So like there is kind of in the wild usually a pretty strong signal of success, which allows for like sort of like iterative trials and improvement and kind of basically sampling. We looked at these like inference scaling curves, like sampling until you find a passing solution, which in that case for the adversary is like, let's say, bring a website down. And the second one is that, of course, in cybersecurity, it is usually a super strong financial incentive to indeed spend a lot of money on, like, for example, bringing a website down. And these two sort of dynamics actually create this like strong incentive for scaling compute and for like and for like improving the capability, the accuracy and success rate on a given downstream task, like in the actual sort of like the deployment scenario. And this can be done a lot across many different degrees of freedom, right? The simplest one is just like retrying and like doing inference compute scaling. The other one is like finding, let's say, similar websites, if you want to stay in that example, where you can sort of like do self-improvement through even like weight updating, like you can fine-tune the agent on like a given task of like, let's say, code injection. And many others that we mentioned in the papers, like the 6 or 7 degrees of freedom that we looked at, and literally for each of those, we could see that the accuracy improvement that we see beats the sort of pass-it-one accuracy that was reported on many capture the flag benchmarks such as Cybench or Intercode. So kind of for cybersecurity, it's even more important to look at dynamic risk assessments over these sort of static benchmarks and just reporting pass-it-one.
Sweet. Okay, Devinder, you're next.
All right. Hi. I have a question about testing. So we made this distinction between agentic testing and eval testing, and I wanted to ask a little bit more about expanding on that and whether you're mapping to functional integration and unit testing that comes from computer science in general.
Agent testing and eval testing, can you expand what you mean by that?
I mean, you did model evaluation is not the same as agent evaluation. I
Oh,
think
model, okay, model and agent evaluations, of course, yeah. So yeah, like this, we again like describe this quite lengthy in the paper, but like there's a couple of key differences that are important to consider here. The one is kind of that usually again like there is this issue of unbounded costs. So if you look at like the common model evaluations, we usually like have text input and text output, right? And like we can sort of like all the scoring just needs to be run on this like text output or image output, etc. But it's like a one-off thing. And for agents, like the scoring is usually much harder because we kind of sometimes want to track some state of the environment that the agent interacts with, right? Such as, let's say, interacts with some database, like what is the state of the database? Did it kind of, in addition to the intended changes, also make some unintended changes that should be counted as like a non-successful task? So the complexity is like just much higher. Then the second thing is like this issue of unbounded costs. So if you consider model evals, we can kind of we don't have to consider so much sort of the compute spent solving a task. But for agents, kind of if we don't look at them, we can actually, especially for downstream deployment decisions, we cannot just look at accuracy and like explain and kind of rely on that only for making these decisions, because this can be very, very misleading, as we have seen from the human eval Pareto frontier, for example, and also on the holistic agent leaderboard website. And the third thing is that like by repurposing model benchmarks for agent benchmarks, we often kind of face these issues of like reproducibility, where, for example, a model benchmark that comes with like unit tests for some problem, like problems like human eval, cannot be used one-to-one on the full test set for agents because yeah, like some problems might miss these unit tests or might like not be amendable to the agent design, and then kind of lead to these sort of like reporting accuracy numbers on like different subsets of the benchmark. So we kind of need to be careful here that like if we look at agent results on a given benchmark, we need to make sure that it's actually an agent benchmark that kind of was designed for agents and does not come with these issues.
Yeah, that's a really good answer. Just looking at my attendees here, some of them have left, but Jonathan, do you want to do the next question?
No, I just wanted to say thank you from before. Thanks.
Okay, no problem. Yeah, please feel free, by the way, to raise your hand so I can see you, because for now I'm just diving into the chat and finding questions from the threads that are really interesting. I'll bring one in about regulatory compliance, if that has come up in the main specific evals for agents, because someone was building finance agents handling KYC in a reliable way, and what the use cases would look like for that.
Yeah, no, this is, I think, a super interesting area. There's like one company, Norm AI in New York, that I think like builds explicit like agents for like that I can just point to that builds explicit agents for like regulatory questions, etc. But of course, like we cannot just think of like agents working on these problems, but also like how can we track sort of like the actions of an agent and whether they are compliant with some sort of like policy that we as a company impose on its actions. And there's a couple cool ideas and like abstractions actually that people have come up with. One company that comes to mind is like Invariant Labs out of Switzerland that kind of developed an approach of like defining these policies of what an agent should and shouldn't do in code. And with that kind of makes them evaluate, like allows us to kind of evaluate compliance with those policies. Like, a policy could mean like, not answering certain questions or like given a task is of a certain type, don't interact with this database and only with that, like, or like only call this tool, not these tools, etc. And that, which is like super hard to evaluate if you don't have like a nice abstraction, but they came up with a way of like defining those very, neatly and makes them evaluatable in that sense. Yeah, then of course, like this whole like this component of like safety and harmfulness, etc. In terms of compliance, I guess also benchmark there is that is interesting. It's called agent harm that we also feature on the holistic agent leaderboard, and that kind of benchmark looks explicitly at abstention. So like how good are current agents at like abstaining from answering certain prompts that we don't want it to answer. How kind of robust are they to like injections by tools they call that might alter their like might want to like cause the agent to kind of go away from the initial task and like achieve some sort of goal from the adversary. And like this whole concept of agent safety, of course, also plays into that. A recent paper that I worked on called the Safety Devolution of AI Agents looks at kind of the effects of like including more context and making more context available to the agents in the question answering scenario. So with more context, I mean not just answering a question from like answering a question like with RAG access to, let's say, Wikipedia versus even like full access to the internet, and how that kind of hurts the compliance with certain rules when it comes to like not producing harmful answers. And we see that kind of more context actually makes it harder for the agent, of course, to like comply with and like abstain from like from giving harmful answers to certain tasks.
Yeah, that's interesting. And Joe, maybe you can ask your question there, because what really it feels like is that the benchmarks just are broken, and there's got to be new approaches and emerging approaches to deal with evaluation.
Yeah.
So
Yeah, it's like the benchmarks are very academic and how they've come about, and they're very hidden away and they're controlled by the academic, and then they're gamed and there's overfitting and all these problems.
Yeah.
So, but if you just the very mention of esports made me think about like just products in the offline world. We've got, website reviews. We have government certification systems that you have to, before you can put a car on the road, you have to pass a crash inspection. You have sports leaderboards. You have awards that are governed by different experts bodies. You've got just independent bloggers who do deep dives. The world has different ways of helping us understand quality of things in the world. So why would it be any different from agents? Or more as a question, what do you think are those new mechanisms that will be most relevant if you look forward, a few years?
Yeah, so I think that's kind of one really nice like toolbox that I like to use when I think about evals is kind of upstream, midstream, and downstream evals, right? Like upstream are these like very academic tasks, like the challenges like little pattern matching, like the ARC benchmark, for example, like that are like have no sort of connection to like a specific task in the real world, but of course like might benchmark some sort of like level of intelligence or capability, etc. Then there's midterm evals, which are like these academic benchmarks. I think those that you refer to, which try to capture a given sort of task from the real world and kind of form some sort of test set that like is to some extent construct valid in measuring accuracy and capability on this task, like SweBench, Web Arena, like basically all of the agent benchmarks these days, I think fall into that category. That is also what we focus on with HAL. And then there are downstream evals, which of course are super hard to like abstract in some sense, because those are like so dependent on a specific deployment scenario, right? That like let's say an agent developer at a given company has, which like depends on like measuring costs, for example, depends on like what models you use, what hardware you run these models. Do you use commercial APIs? Don't use commercial APIs? Like how often does the environment change that your agent is operating in? Let's say you have new products that you're launching. Is it like on a weekly notice, monthly notice, etc.? Like what kind of users and like people do interact with your agent? Like there's so many degrees of freedoms that makes it like basically impossible for like a downstream eval to be abstracted to become a midstream eval. And I think the crux is really like, how do we for this like new step into language agents, but then of course also embodied agents, find like a way of making midstream evals closer to the downstream context, right? How do we measure something that is indeed construct valid, and measures capability that is informative in a way for like downstream use cases? And I think like as you said, like one cool way of like doing that, and especially like focusing on capability and a little bit away from like these downstream use cases, would be like to look at dynamic context, right? Like you sort of like, if we no longer can build evals and like static benchmarks that are like hard enough for like developers not to overfit and kind of crack them and like over time, we can look at dynamic context. So let's say we pitch agents against each other, right? Like have them play some sort of game or like code against each other. There's this a cool example called Agent Village, I think, where agents were like pitched against each other to like raise money for like a good cause, and had like 30 days time to do that. So I think these are sort of like examples, or like I think there's another one called the Agent Hedge Fund, where like agents try to make to kind of make money by investing on the market in some toy scenario. So these are kind of cool examples where there's like a concrete task that is like relevant to the real world. But we do not rely on some sort of static benchmark set, right? That is like too academic, but it's like something where there's competition, where there's like some sort of dynamic environment that is evolving, and where the agent needs to adapt to that environment. And I think for the case of embodied agents, one really cool way that we have also used since 2,800 years for humans is like sports, right? And like looking at like these sort of like super hard physical tasks of like sprinting, playing basketball, interacting with external objects, etc. And we can create these dynamic sort of multi-agent settings to benchmark capabilities without ever defining some sort of static task that can be like hacked to some extent.
Okay, I mean, since I run a nonprofit, I'm definitely going to research AI agents collaborating to raise money
It's
for
called the
the
Agent Village. Yeah, it's done by Digest, I think. Yeah.
Yeah, that's really cool. There was a question about multi-agent situations and coordination and what to do there. Let me just try see if I can find the original question. And
Yeah, kind of
just
my two cents on that is like that like the work I did myself on like multi-agent settings is that For multi-agents, first of all, looking at cost becomes even more important, right? Because like sometimes you can measure an increase in accuracy by using multiple agents versus one agent, but that ultimately comes down to like these multiple agents, let's say, just having basically more attempts to solving the same problem. And with that kind of also incurring much more cost, but like, bumping the accuracy numbers on some on some benchmarks. So like if there's a strong verifier available, then the baseline here should always be what is the pass at, let's say, 5 of the single agent versus using 5 agents in like some sort of multi-agent scaffold to accomplish that task. For settings where there is like no verifier available, I think moving from single to a multi-agent is something that we need to think about as like a task-specific optimization. So like if you look at many of the current multi-agents scaffolds that are used, the one like by AutoGen, for example, and like many others, they have multiple agents that are optimized to achieve a certain task in the pipeline. Like, this is my web surfing agent, this is my like coding agent, this is my planning agent, etc. And like I'm a strong fan of that because task-specific optimization indeed show kind of that you can increase accuracy a lot by only very minimal sort of like engineering effort. So if for tasks where there's no verifier available, I think there is some pretty cool work going on with like doing task-specific optimizations to improve accuracy. The question there is more, I think, what really like distinguishes a more complex single agent scaffold from like a multi-agent setting. If all we do is kind of giving like let's say language like single language models like special roles, etc., and putting them together to like coordinate to some extent. Like this is kind of a sort of a definitorial, like a question of definition. Yeah, this is kind of my thoughts on that.
Yeah, it's we will need to wrap up very shortly. I want to ask more questions here. There was a question about when benchmarks become compliance and interoperability between benchmarks. There's so many more questions we didn't get to. But please share the deck with us if you don't mind, Benedikt. And thank you so
Of course,
much.
yeah.
And any suggestions for papers that you think we could feature? Because we're on a roll here. And so the more papers that are good, the better. If you think of seminal papers to the topic of agents, we'll continue to be doing that dive. But thanks everyone for coming. And we'll see you in a week because we've rescheduled this one. I will quickly drop a link to the next event. Just bear with me. And you can drop a link to where people can find you. I know we have many regulars by now, but we're continuing to talk about benchmarking. We'll do benchmarking LLM agents with Microsoft and Carnegie Mellon researchers. And the paper is The Agent Company. So I will drop a link for you. Please RSVP. It will be great to just keep talking about benchmarks for another session. So yeah, thanks everyone. And Joe, do you want to say a few words before we wrap up?
No, thank you. Feedback is welcome and ideas, suggestions, and all of that. So please chime in. And if you're in one of these cities and you haven't been to an AI Tinkerers, please go. That's for builders who are actively building to share your work in progress, your side project, something you're working on, and to do a walkthrough to enable a fellow tinkerer. So it's not a pitch forum, it's very much a builder forum. So we'd welcome you if you have that to contribute.
Yeah, and those of you in Toronto, our next event is on June 18th. I'm just dropping the link again to the chat, to the page, so please come. And yeah, we'll see you next week. Thank you so much. Thank you, Benedikt.
Yeah.
Thanks so much, everyone. Great to be here. Thanks.
Thank you. Bye.